Okay. Good morning, everybody. Welcome. Welcome to our ZEISS CMM webinar for the Australian industry. My name is Josh.
I'm Ben.
And we're joined by Thomas from ZEISS in Sydney. Hello, Thomas.
Hello, everybody. Thomas from ZEISS. I'm happy to join Josh and Ben from Scan-Xpress today for the ZEISS CMM webinar, providing a bit of support, and let's see how that goes with your questions later on down the track.
Yeah, great. Thank you. We've got the webinar is going to go for about half an hour. We've got a Q&A session at the end, so if there are any questions that you think of during the webinar, please put them in the box, and we'll get them underway at the end. But let's get started. Let's start the webinar.
Sounds great.
Enjoy.
For today's agenda, we will start with a brief introduction to Scan-Xpress and ZEISS and an overview of the ZEISS product portfolio. We will then discuss various CMMs and sensors offered by ZEISS and move into examples of this technology in use in the Australian manufacturing industry. We will end with a Q&A, so please use the chat window to ask any questions as we go. Scan-Xpress pride ourselves with offering the highest quality measurement systems to the Australian and New Zealand market, with service and support as well as system sales. Our long-standing relationship with some of the world-leading metrology companies has enabled us to work alongside some of the biggest innovators and manufacturers on the continent. Our experienced and knowledgeable team is based throughout the territory, and we offer both on-site expertise and project-based support for all metrology, reverse engineering, or 3D printing requirements.
ZEISS is a global multinational company specializing in optical technology. Founded in 1846 by optician Carl ZEISS, the company has grown to become a leading innovator in measurement technologies and techniques. Some of their recent notable advances in technology includes industrial computed tomography and X-ray systems, which are a game changer for industrial metrology. Additionally, they have now acquired the world-leading GOM industrial metrology, thereby adding structured light scanning systems to their product portfolio. However, the focus of today's webinar will be mainly focused on multisensor CMMs. Just to give you an idea of the ZEISS footprint, here we see their overarching global presence. Notably, ZEISS are market leaders in industrial metrology in Europe, the US, and Asia. Their technology has been widely adopted and accepted in a wide variety of sectors, including aerospace, automotive, rail, transportation, and energy. While they had a strong presence in Australia 20 years ago, with the slow decay of the automotive industry, the install base has since dwindled. With the acquisition of GOM and new partnership with Scan-Xpress, it is our aspiration to restart ZEISS activities on the continent, especially now that Australian manufacturing seems to be on the rise. Currently, there are approximately 60 CMMs installed in Australia and a tech support team of 3 engineers, which doesn't include the Scan-Xpress team. We will show you now a quick 1-minute video which highlights the ZEISS Industrial Metrology applications, mission, and ambitions. As you saw in the previous videos and slides, ZEISS offers products and solutions in a wide range of industries and applications. Shown here is the full portfolio range of the ZEISS Metrology branch. As you can see, this includes R&D and lab tools such as CT, X-ray, microscopy, and much more. Today we will focus on the products highlighted in the top right, which consist of CMMs and multisensor measurement machines. These are intended for applications in manufacturing and industrial quality control, and inline inspection, as well as incoming goods and first article inspection. In the next few slides, we will showcase 4 ZEISS CMMs, which will help provide some context for our 9 industry application examples.
With the ZEISS Spectrum Coordinate Measurement Machine, you will enter a new level of precision with trusted results at an unmatched price-performance ratio. The ZEISS Spectrum CMM delivers scanning technology as standard. This gives more reliability and repeatability of measurement results due to a massive high point density for evaluating size, form, and location tolerances. Both active and passive scanning technology can be used with the Spectrum system. This enables optimum accuracy independent of form position errors due to the actively controlled measurement force. The ZEISS Spectrum family comes in different packages for either single point measurement, scanning mode, or with RDS for complex structures. This enables easy decision making based on the application. This is a great entry-level solution for a wide range of applications throughout many different industries in the Australian market. This will be demonstrated in the application examples as a preferred system for basic applications where point measurement or surface scanning is required. The CONTURA system offers complete flexibility to the measurement process. 7 different sensor types with 3 different capture technologies, optical, tactile, and scanning, can be integrated to design the best metrology solution for each application. The optional integrated rotary table gives high performance measurement in the 4th axis. With several automation options, this system delivers adaptability and flexibility. The CONTURA has a small footprint, but because of the ZEISS innovation, this does not impede on the working area of the CMM. The integrated backpack controller box with heat reduction results in a large working area with no loss of measurement space. This system can also be used with the ZEISS ProMax. This is a multi-sensor rack which can be used to optimize the measurement volume. The ProMax works by automating the tool change process by moving the required stylus into the measurement range only when it's needed. This can increase the potential measurement area by 46% compared to standard sensor racks. With the MAS technology, a large number of ZEISS sensors can be operated with high precision and quickly replaced in the same measuring instrument. Sensors with articulating probe holder or fixed probe configuration, optical or tactile, passive or active. This is how CONTURA achieves maximum flexibility. This system is the go-to solution for a large number of applications due to its flexibility, speed and accuracy. This will be demonstrated later in the application examples as the choice for a large number of processes. Now, back to Josh.
The DuraMax is an awesome tool for businesses and manufacturers looking for robust inspections on the shop floor. It features a small footprint with an intuitive user interface. It is designed to integrate easily into your existing workflows, and it is capable of capturing a high number of points using vast scanning sensors, allowing it to quickly evaluate surface form and tolerances. With the ZEISS VAST probing mode, faster single-point measurements can be achieved. This in turn can lead to a significant reduction in measuring time and ultimately increased throughput. DuraMax offers a complete and robust package with software, CMM, probe and accessories integrated seamlessly. The probe is designed with thermally stable material torque, which guarantees the repeatability of your measurements despite temperature variations. Overall, this is an excellent solution for Australian manufacturers looking to replace gauges or manual measurement processes. It will allow you to improve your throughput and repeatability while detecting more defects and digitizing measurements and your results. The O-Inspect is a multi-sensor machine combining the benefits of both optical and touch probe metrology into one single package. It allows you to use a wide range of sensor technologies interchangeably with speed. It comes in a variety of sizes and configurations tailored to your application. It comes equipped with Discovery V12 image processing sensor, allowing you to visually inspect with magnification capabilities up to 15 times. The vast XXT contact sensor enables precision scanning or single-point measurement for critical feature inspection. The system can also be equipped with a confocal white light sensor ZEISS scan. This combination is a perfect match for small parts or delicate surface finishes. The O-Inspect is well suited to plastics and electronics manufacturers that produce precision machined or molded parts. Other components like connectors and PCBs are also well suited to being measured on the O-Inspect. Before we delve into the application examples, let's take a quick minute to explore the main sensor types that will be shown during the rest of the presentation. Starting from the left, the vast XXT is the base contact sensor type offered by ZEISS. It is a scanning sensor by default, not just a single point measurement sensor. This means that it traces along contours and surfaces, providing much more accurate measurements and a higher density of points with huge time savings. The line scan is the ZEISS optical solution compatible with the versatile CONTURA CMM. It captures 700,000 points per second and can offer full field data capture. It does all this without requiring contact with the surface, which can prevent scratches or damage for sterile components or fragile surface finishes, such as medical devices. The vast XT Gold is an active scanning sensor. The probe head allows for continuous measurements across complex or freeform surfaces and grooves, and can provide greater accuracies than the vast XXT. The RDS is an articulating probe holder, which will be shown in multiple applications in this presentation, as it enables contact measurements of virtually any complex part or geometry. I'll pass it back to Ben, who will start us off first with a local success story before we get into our application examples.
Before we start with the application examples, let's have a look at a ZEISS metrology solution currently in operation here in Australia. Thales are a world-leading innovator of advanced weapons solutions and a key partner to the Australian Defence Force and the Royal Australian Navy. When Thales Australia was planning the future of the Lithgrow arms factory, it was recognised how crucial it is to incorporate advanced quality inspection equipment into their manufacturing processes to stay competitive. They now use 2 CONTURA scanning CMMs to ensure precision of these processes every step of the way. Multiple sensors can be used in different inspection requirements with these systems, which are integrated using the ZEISS Calypso software and PyWeb. For these application examples, we will identify a component type and go through an example of the manufacturing process, including where quality gates could be inserted to achieve maximum performance. We will also identify the relevant ZEISS system or systems which could be used at each quality gate. We're going to generalize a bit to ensure no proprietary information is released. You'll also be able to see the key benefits to each process in the bottom right. The Australian aviation industry has been the backbone of Australian manufacture, with world-leading companies like Boeing and Airbus driving the requirement for precision parts for various applications. High precision, small to medium-sized machined alloy parts are a common requirement. In this example, we show a simple mounting bracket. The process for manufacturing this type of component would be to start with a billet of material and go through several drilling and milling processes to get the final part. A jig or fixture change will be used to turn the part, which could introduce deviation into the process. The other main challenge for parts of this type are the tolerances, either GD&T or dimensional. In order to guarantee a smooth and efficient process while ensuring high level of quality and defect detection, Multiple gates should be inserted into the manufacturing process at locations that do not impact the overall flow. At the first jig change, we may want to measure the external profile and certain critical pass-fail dimensions. This will allow us to ensure we are not continuing to put energy into an already defective part. The second quality gate could be placed at the end of the milling and drilling of the internal contours and mounting holes. This will ensure that all rework is performed before the surface treatment is performed. The final quality gate will be an overall and in-depth measurement, taking the most time to ensure the required tolerances are met before shipping. Since this component has relatively simple profiles, basic surface treatment, a solution such as the ZEISS Spectrum with the vast XXT sensor would be sufficient, as point measurement and contact scanning is all that's required. This example will be similar to the previously discussed mounting bracket, but may introduce more complex or freeform surfaces or tighter tolerance requirements. The manufacture process would be similar, but the ZEISS CONTURA CMM could be used instead of the Spectrum. This is because the CONTURA offers the flexibility in measurement by offering optical, tactile and scanning technology, whilst increasing the potential accuracy of the measurement. As with all metrology systems, matching the required tolerance with the correct measurement system is a critical step. Josh will now take us through the next few applications.
Thank you, Ben. Here we have an orthopedic knee insert example, which requires customization for each production part, as well as a sterile environment. The process begins with the modification of a custom mould to fit the patient's exact knee sizing. The mould is then used to create the first draft of the implant, which then goes through multiple forming processes. Multiple quality gates are used to ensure the implant will be a perfect fit for the patient's bone structure. A contact scanning sensor, such as the vast XXT, could be used for a majority of the quality gates. The final checks performed on a sterile and highly polished surface may warrant the use of a non-contact optical sensor, such as the line scan. It is important to note that recent advancements in technology have allowed orthopedic implants to be constructed using additive manufacturing processes, which can save time and money, especially given the customization requirements of the implants created. This is becoming more and more common and may help eliminate the need for certain quality gates shown here. We will explore an additive manufacturing process in a few slides' time. To delve further into the mold design and manufacture process, let's explore how a precision metal die or tool fabrication process could incorporate quality gates to ensure the final geometry produces components that fit specifications and tolerance requirements. A first prototype of the tool is produced based on the design of the desired output component. The surfaces can be measured using a scanning contact sensor such as the vast XXT to ensure it matches with CAD design expectations and critical geometries are within tolerance. A prototype end-use component batch run would then be produced from the initial mold or die. Optical metrology solutions such as the GOM 3D scanners could then be used to produce digital twins of the prototype mold and the parts for analysis and design iterations. ZEISS offers a revolutionary software tool, ZRE, or ZEISS Reverse Engineering, which allows you to perform tool corrections based on digital iterations of your mold, allowing you to arrive at a final die solution faster and with less time spent remachining. For those of you interested in this solution, note that ZEISS offers a free trial of this software. Next we have a similar example, this time with plastic injection parts. The video displays a plastic crate used in food processing and packaging, an industry that is quite large in Australia. However, this process can be applied to any plastic injection component. The video shows the software ZEISS Reverse Engineering and its tool correction functionality that I previously mentioned. We can see a combination of measurements from multiple ZEISS measuring systems, CMMs and handheld optical metrology, to ensure the final product matches specifications. In a typical plastic injection manufacturing process, we may want to use 1 or 2 quality gates depending on the tolerances required for the final product and the certainty and repeatability of our mold and injection process. Here, we show the O-inspect being used to measure components pre- and post-assembly. The optical and contact sensors can be used to measure intricate details on the surfaces as well as overall assembly fit. This type of process would typically be used in medical device production or assembly, such as face masks or ventilators. It would also apply to consumer goods or electronic casings where precision becomes important. The OInspect is a great tool for these applications since it offers huge flexibility at an attractive price point. In this next example, we wanted to showcase an at-line inspection application. Here we see a small to medium-sized gear and housing manufacturing process. The gear and housing are manufactured using conventional die casting and CNC machining. Typically, these parts would be produced in an uncontrolled warehouse-type environment, with many Australian manufacturers still relying on manual tools and gauges to perform inspections. A production floor CMM, such as the DuraMax, could easily replace manual processes that are operator-dependent, unreliable, and can be a liability for final product quality. Furthermore, the use of a Shopfloor CMM would allow all quality checks to be digitized and saved automatically, which also provides traceability for the manufacturer. Although the capital investment required to replace manual inspections with a CMM is high, the long-term benefits and cost savings are well documented, as we see more and more companies stepping away from gauges or manual tools across all industries. In both the housing and gear manufacturing process, the DuraMax Shopfloor CMM could be used to perform dimensional checks. In order to ensure an efficient process, these quality gates should be combined with jig or tooling changes. Final quality inspections of the finished part could be performed using a separate CMM in a more controlled environment. Here we show the CONTURA, used with an active scanning sensor, allowing for quick measurement of the gear teeth and the housing surface geometries. For this next slide, we have an amazing video to show you from one of our international customers, Toolcraft. Here we will explore how multiple metrology solutions, shown on the right of the slide, can be integrated into a modern, high-precision additive manufacturing process. The video was filmed in partnership with Toolcraft Germany.
We are using the measuring technology from ZEISS for additive manufacturing. For us, ZEISS is the only company with a holistic solution that can document the entire process chain. Industrial parts melted layer by layer from powder. 3D printing is revolutionizing manufacturing. But additive manufacturing also means big challenges for quality assurance. With ZEISS 3D Manufact, ZEISS offers a holistic quality control solution for every step of this production technology. Toolcraft in Germany has been active in 3D printing since 2011 and specializes in manufacturing precision parts for the automotive, semiconductor, aerospace, and medical industry.
Benny, hi. Wie schaut's aus? Können wir den Baujob dann starten? Bei der additiven
In additive manufacturing, it's important to monitor quality throughout the process. As it's a new technology, it needs to prove itself to gain the trust of the customers. Quality assurance is of utmost importance for Toolcraft. We supply to the aerospace and medical industry, where quality is a fundamental requirement. This is done via a series of integrated measurement tools from ZEISS, the ZEISS 3D Manufact. This solution makes it possible to gather quality data along every step of the production process. First, the metal powder is being mixed with a synthetic resin and prepared. The grinded powder sample is now being analyzed with the ZEISS Axio imager. Using the microscope, I can analyze the powder particles. Different lenses are used for image sharpness and detail. Now, through selective melting of the powder, complex parts can be built. In parallel with each job, samples for a range of tests are being printed. The raw part, a blade segment of a gas turbine, has now been printed. I can now examine the readily printed part with my 3D scanner. The part is being analyzed for deformations with a fringe projection scanner. After that, the part is checked in a CT to ensure no critical pores were created inside the part. The samples that have been printed in parallel are being polished and carefully examined.
Hier kontrolliere ich die Oberflächengüte einer guten
I'm checking the surface quality of a good sample compared with that of a poor sample.
Einer schlechten Probe.
Using the ZEISS AxioZoom V16, porosity and crystallographic structure are being analyzed. Having passed this additional test, the raw part can be machined. The machined part is now being tested for dimensional accuracy and surface quality using the tactile measuring technology of the ZEISS Accura coordinate measuring machine. Finally, all data is organized with the ZEISS software PWeb and compared to the CAD file. The results can be documented in reports. The primary advantage of the ZEISS solution is consistency and its compatibility with our systems. It's very important to collect data consistently using one single vendor. This way, we can perform automated quality assurance very well.
As we can see, for precision components using additive manufacturing methods, many quality gates are used to ensure the material properties, as well as the part form and function, align with design and tolerance requirements. I'll now pass back to Ben, who will finish with our last two application examples.
In this next example, we'll look at Turbine blade, which offers sizable challenge due to its complex curve profile and tight tolerances across the whole surface. The process shown would be typical for the manufacture of low-pressure blades, but similar quality gates would apply for HP, compressor blades, or fan blades, with obvious minor changes. In this example, special alloys are cast into a pre-existing mould to achieve the rough shape. The first quality gate could then be placed once the rough exterior geometry is complete. Active scanning would be a preferred method, as it would allow for full data capture and precise measurement of the critical exterior dimensions of the part. Another detailed quality gate could then be placed after the blade geometry is further defined and cooling holes are drilled. Due to the small size of the cooling holes in such a part, an optical sensor may be used for these measurements. Active scanning would now allow us to accurately scan the curved blade surface and ensure that the designed form and tolerances are met. The final dimensions are checked after the surface coating. This would ensure that no critical dimensions were altered during the coating process or missed at previous gates. The final example we will showcase is a carbon fibre laminated component. The workflow shown is applicable to lots of composite moulding processes and starts with a hand lamination of material strips in a pre-existing mould followed by an oven cure. The first quality gate could be placed after the part cools, allowing us to ensure certain critical dimensions are met before investing more time and energy into the part. After trimming the excess material and machining key contours and features, a second quality gate could allow us to validate that the precision machining work was completed properly. Here we show a combination solution involving both the CONTURA and the O-Inspect, which will allow us to manufacture at a higher rate, reduce quality control bottlenecks. The O-Inspect is a suitable solution for measuring small to medium-sized parts and is more cost-effective while slightly less versatile than CONTURA. A final quality gate, after surface finish and polish is applied, could be completed using an optical scanning sensor. This would ensure that we are not marking or damaging the final product, whilst allowing us to validate the finished surface and part profile. This concludes our application examples, and we will now answer any questions.
Yeah, wonderful. Thank you very much. We'll just wait for a few minutes for any questions to come in, because we're on maybe a slight delay. A recording of this webinar will be available, so we'll send out a link to everybody, so feel free to share that within your organizations. But yeah, fantastic.
Right, so yeah, still waiting for any questions that might come through. Thomas, do you want to tell us a little bit about your history and your experience with ZEISS quality systems?
Yeah, sure. I've been working with the company ZEISS for the last 30 years, sort of spending quite a bit of time over in Germany at headquarters, basically learning sort of the process and the development of the ZEISS metrology, products, and sort of getting to know the original ZEISS scanning machines, which were developed back in the late 70s, early 80s, and sort of gradually got through the current way of how CMMs are now operational, optical sensors and so on, and that was something which wasn't available back then. But it was very interesting to see how ZEISS is progressing in their development, and always be one step ahead of of the competition in a way. Also being an optical company, optical sensors are really the main thing where ZEISS is very, very strong in it, in addition to the tactile probing. Yeah, great. Thanks very much for that. Well, we're relatively new, as at Scan-Xpress, relatively new to the ZEISS technology. We historically have been the distributors for GOM, optical metrology systems, in Australia and New Zealand, and since ZEISS bought GOM, now we've developed this working relationship, which we're really excited about. So we appreciate you taking the time to join us on the webinar today. Yeah, absolutely. It's going to be great to work together with Scan-Xpress from now on forward. It's always it's fantastic to have some extra people on the ground and supporting our customers here in Australia and New Zealand. Yeah, great. There isn't any questions that have come through yet, so we might just wait another couple of minutes to see if we get anything. Have you got any other thoughts?
No, just if you've got any questions directly relating to maybe some of your current processes, please get in touch with us directly. You'll have our email address from the webinar link, or you can contact us on LinkedIn.
We've got a question from Lenice. Lenice has asked, can you tell us a bit more about how the different software packages interact? Example, Calypso, reverse engineering, OInspect, etc. So maybe Thomas, you can take that one for us. Yeah, sure. Calypso is the software which comes with every coordinate measuring machine, and there's optical and optional licenses also in regards to the reverse engineering software to actually link into Calypso and basically have all that software being interacted with the actual ZEISS hardware. So you're basically getting a product where all software actually works with the hardware. So with ZEISS, all the hardware and software products are actually manufactured in-house, produced in-house. So there's no third-party company to talk to. So whatever software and hardware is available through ZEISS, that's always coming from ZEISS. Okay, great. So all of the CMMs. What about the vision systems like OInspect and ODetect? Do they also work on Calypso? Yeah, also the vision system. So all the ZEISS CMMs, optical and tactile, they're all the base software is always Calypso. So when you buy a CMM, you don't need to specify anything about the particular software. Calypso is always the basic package of the CMMs. And then in addition, there's other additional licenses available for reverse engineering, and also PyWeb for data management, and so on. Okay, great. Got another question from Mike. Mike's asked, could Thomas give us some background to what's involved in programming the CMMs? Yeah, the programming is quite straightforward. So you can either run the programming through just by having drawings of the part, and you basically do a learn programming of the actual geometries. Alternatively, would be if you have a CAD model, then it's very simple. You virtually load the CAD model into Calypso and just click on the feature that you're interested to measure, and it basically creates the program that way. So it's very straightforward. Okay. It doesn't sound like it's a long, tedious process. Sounds like it's pretty fast and straightforward. It's very, very straightforward. That's right. Yeah. That's right. Yeah. Of course, it is a little bit easier when you have CAD, but it's not a must. Yeah. Understand. Okay. Great. Thank you. There's no other questions. Maybe we can think about wrapping it up. Just give everybody another minute, maybe, to come up with any questions. No? Okay, maybe we'll wrap it up there. We'll provide a recording to everybody that's registered and everybody that's attended to the webinar. So thank you very much for attending, and thank you, Thomas, for your help. We've got another question.
Pleasure.
From David. Is ACROM training to be available in Australia, in-house, not online?
ACROM training do you refer to AUKOM training? AUKOM?
I think he might be referring to our
Yeah. So that's a training which we can provide as a web-based training. So a virtual training, a remote training, whatever you want to call it. So yes, that is available. That can be arranged.
Okay, great. Carrie Armel says, "Hello, Thomas." Nice friendly message there.
Okay, yes. That's somebody I know.
Great. Carrie Armel has also asked, can you elaborate a bit more about reverse engineering and die-cast components? Ben, do you want to take that?
No, I think that's another
one for Thomas. Okay.
So in the die casting process, I've got the sort of a cheat sheet here. So for the die cast process, would that be for tool correction? Is that what the question is?
That's possible, yeah.
Yeah. So for the reverse engineering software is basically a 3D CAD model software, and the measurement point and the cloud data is unlike a conventional software. It basically takes direct surface points from the cloud data, and that's the benefit instead of creating triangle meshes. So it's a far more specific way and a more accurate way of actually getting the data points. So that is really the benefit of that particular software. But I mean, it's sort of a very wide application, and I think it possibly would be best if there's really a deep interest for that software. We should maybe take that offline and then maybe do some sort of a demo on that particular software.
Yeah. So Carrie Armel's just also clarified to solve casting issues, dimensional issues on casted parts. I think maybe we can reach out to Carrie Armel after this and have a bit more of a discussion about it. But I do think that yes, the ZEISS reverse engineering software could definitely be a help for this application.
It will be definitely. Yes.
I've got another question here from Aman. Aman said, "Hi Thomas, can you please highlight some benefits of the ZEISS CMMs over others?"
Yes, there's certainly with its ZEISS CMMs, you particularly when you're looking at the models sort of from the CONTURA type onwards, they are multi-sensor CMMs, and you basically they're very much future-proof to the point. I mean, first of all, you could maybe start with a CMM and just have tactile probing, just tactile scanning probing. And then down the track, if your production needs a change, you could then always add additional sensors, optical sensors, and so on. Maybe even a surface roughness sensor to go on the machine. So it's something you can always retrofit later down the track. Also, the scanning capability of the ZEISS machines. ZEISS has got a patent on the active scanning technology. Active scanning means that the probe head itself has got a probe force generator. And the probe force generator will allow to apply a particular probe force for a particular probe, which means because the probe force is known, the bending of the probe, which there's a little bit of a bending at all times when you actually do a probing on a part, that bending will then be calculated out, which means if it bends by say half a micron, it actually calculates that half a micron out. And hence the accuracy of the ZEISS CMMs is very superior over other technology.
Okay, great.
Yeah, wonderful.
And it's good to know that the everything's fully upgradable, so it's sort of going to be able to grow with your needs. Initially, you can purchase whatever sort of system you might have for a single requirement, and then add on to that as your requirements change or grow. It's great.
That's right, yes. And we also have CMMs like they have been installed back in, say, in the 90s and so on. And even now, if speed is not of essence, because those machines are a little bit slower than the current machines, they can still be upgraded to the latest technology. So you can still upgrade them to the latest sensors, and you can upgrade them to the latest software, which means that you have a machine which outlasts a lot of other CMMs which can't be upgraded.
Yeah. Okay. Great. And I suppose looking at things like CMMs and any way to sort of digitize your measurements is very important for modern manufacturers looking to keep up to date with Industry 4.0 and new innovations in manufacturing.
Yes.
Yeah. Okay, great. I don't think we've got any more questions, so maybe we can wrap it up there. We'll we'll provide a recording to the webinar and send that through to everybody that's registered. Thomas, thank you very much for taking the time to spend the time with us today and sharing your deep knowledge with the systems. Okay.
Wonderful.
Thanks, everybody.
Okay.
Bye-bye.
Bye.
Okay. Bye all. Thank you.